Welcome to my first calculus video. I intend to stick mostly with SAT, but I got a request from one of my favorite former students, a fabulous person who has a calculus question. So here we are with optimization in a business context. We want to minimize costs and find the objective equation and constraint equation. The objective equation is the equation that describes your objective, your goal, the object of doing this math. And our goal is to minimize costs, so our objective equation will be the cost equation. C of x, the cost for x shipments. I'm going to define x equals number of shipments. And the cost for x shipments equals $2 for each order, so that will be 2x plus some sort of carrying cost that I'll worry about later. If x equals number of shipments, I'm going to use n equal number of whatsits in each shipment. And I need a constraint equation where the objective equation is the quantity that varies where you want to find a maximum or minimum to meet the object, the goal of the calculus. Your constraint equation is something that's always precisely and exactly true and constant. Here our constraint is we're going to sell 1,200 whatsits. Whether we have 1,200 shipments of one whatsit or one shipment of 1,200 whatsits, we're going to sell 1,200 whatsits. So our constraint is the number of shipments times the number of whatsits in each shipment is 1,200. Now I just need to figure out my carrying costs, and the carrying costs are $3 per whatsits for the average number of whatsits in inventory. And that's a hard thing to figure out, so I'm going to make stuff up. I'm going to try a couple of examples that are easy to work through and see if those suggest a general formula. So my inventory versus time going out to 1 year. If I only have one shipment, I start at 1,200, all 1,200 whatsits. I should write legibly. I start with 1,200 whatsits. At the end of 1 year, I have 0. And my average inventory is going to be the area. And the area of this triangle is 1/2 the base, which is 1 year, times the height, which is 1,200 whatsits. So the average inventory is 600. What if I had 2 shipments? Then my inventory versus time at 1 year and 1/2 year. My inventory is going to start half as high at 600, and it'll go down to 0 by 1/2 year. And then I get my second shipment, and that goes down to 0. And we're selling whatsits at a steady rate, so I am right to draw these as triangles. So my area is 1/2 the base, which is 1/2, times the height, which is 600, which is 150 here and 150 here. So my total average inventory equals 300. And if I did 3 shipments, I would start with 400 whatsits, go down to 0 linearly because I'm selling at a constant rate, jump back up to 400 when the second shipment comes in, go to 0, third shipment comes in, and again I go to 0. And my area for each is 1/2 the base of 1/3 times the height of 400, which is, and then I have 3 of them. So that is a total average inventory is 3 times 1/3 is 1, times 1/2 of 400 is 200. So my average inventory went 600, 300, 200. My average inventory is 1200 over X, where X is the number of shipments. I think I'm fairly safe in generalizing. So $1,200 over X, where X is, no, it is 1/2 1200 over X. So X equals 1, I got 600, that works. X equals 2, I got 300. Half of 600 is 300. X equals 3, I got 200. And 1200 over 3 is 400, half of that is 200. So that is working for the first 3, and it's reasonable if you look at my area calculations. So my carrying cost here, carrying cost is $3 per what's it for the average number of inventory. So my carrying cost is half of 1200 is 600 over X times 3 is 1800 over X. Now I have my objective equation and I have my constraint equation. That's what they asked for. I'm done. No, I'm not done. With math, there's always more. They said do not solve, but I have an equation here that's aching to be solved. So let's solve it first by taking the derivative. C of x equals 2x plus 1800 x to negative 1. So C prime is 2 minus 1800 x to negative 2. At the optimum, that derivative will be 0. So that's 2 equals 1800 x to negative 2, or 2x squared equals 1800. And I was a little worried, what if I get a fractional what's it? Do I have to worry about whether I'm allowed to split my what's it? But it's looking good. X squared equals 900, which gives me x equals exactly 30 what's-its. That is the critical point. I have to find out whether it's a max, min, or neither. And I can do that 2 ways. First of all, I can take C double prime, which is second derivative. Derivative of 2 is 0. Derivative of negative 1800 x to negative 2 is positive 3600 x to the negative 3. X is positive, 3600 is positive, so this is greater than 0. If the second derivative is positive and the first derivative is 0, you have a relative minimum. And if you're wondering about that, look at y equals x squared, y prime equals 2x, y double prime equals positive 2. Second derivative is positive at all points, and in particular at the critical point, x equals 0, and that is a minimum. And you know there's a relationship between second derivative and max or min at a critical point, so that will help you remember that if the second derivative is positive, you have a relative minimum or a local minimum. So we have the minimum cost at x equals 30, and if x equals 30, our n, our shipment size, is 1200 over 30 is 40. And our cost, C of 30, not 3, is twice 30 plus 1800 over 30 is 60 plus 60 equals 120. So we were able to solve it. One other thing we can do with this you should more or less be able to sketch this from your knowledge of functions. We know that y equals 2x looks something like this. And we know that y equals 1 over x looks like this, so y equals 1800 over x looks the same other than questions of scale. If I add these two, so I have something with a vertical asymptote at 0 that goes to 0, and I'm adding it to something that's just sloping upward. The combination should look something like this. Y equals 2x plus 1800 over x. Looks like this curve, and it does have a minimum, and we just found that should be at 30, 120, where my horizontal axis is x and my vertical axis is c of x. Let's try that on the calculator. Y equals 2x plus 1800 over x. For a wind, I'm going to take x max 60, which is twice where I already know my minimum is, and y max maybe 300. Graph. And the graph looks like this. And this is x equals 60. And this is y equals 300. And my graph looks something like this, which is similar to what I sketched from our knowledge of linear functions and the inverse function y equals 1 over x. So we were able to identify the constraint equation, which is the requirement that's always true that relates variables we may express, our objective equation, which is our object, our goal, minimize cost, so it's the cost equation, and we found the solution that they asked us not to solve. Come back soon for my next math video. Whether it's SAT or calculus, there's always more math.